Warzone. The way I like to think about quantum numbers is that they give an electron its address. You have your home address where you probably are located, especially right now since as of this recording we're in the middle of a pandemic. Quantum numbers are kind of like the electron's address. Excuse me, I have to figure out where I'm going to jump.
Battle Royale.
Let's go out here.
Mark a drop point for your team. You'll lead them in.
So,
Avoid the
take the
gas,
president's
enter the safe
address, for example. No, the current president. Thank you. Why do people always jump out at the very beginning? Even if I wasn't recording, I'd be way out there. Strategic. But if you look at an address, yeah, that. As you go from the bottom of an address to the top, things get a little more specific to where you may be located. You know, at the bottom, you've got the state and the city in that state, and then you have the street in that city, maybe the house number in that street, and so on. That's kind of what quantum numbers do. You know, as you go to each quantum number that we talk about, you get a little more detail where that electron is probably found. So the first quantum number that we look at, is anybody around me? Is the principal quantum number, which is represented by the letter N. You may remember from our talk on Bohr and Rydberg's equation, both of those guys' equations had an N in you know, Rydberg's N was, again, just numbers, his was database, but Bohr's was based on theory, and in his theory, those N's represented the different energy levels that you might find an electron. I ain't gonna make it. So, in the quantum model, the quantum number N,
Eliminate all targets in the AO.
it's the same, pretty much the same N as Bohr. Bohr's N in his theory. Although we do use the term shell instead of level. Where's the crate? I don't know for sure, but I've always thought it's because
Enemy personal radar in the air.
shell makes you think more three-dimensional, where levels are kind of flat, which is, you know, kind of where, you know, kind of what Bohr's theory was based on. Oh, I didn't get but yeah, it's more or less the same N. We're just kind of thinking about it a little differently. So if we're talking about the first shell, it's pretty much the same as Bohr's first energy level. But that's where Bohr's theory stopped, you may recall. And what Bohr couldn't figure out, what it took people later on a little time to figure out, was that it didn't just stop at levels. These levels had sublevels, or as we say it now, these shells have subshells. And a shell is represented by, you know, the letter N, the principal quantum number. These subshells are represented by the angular momentum quantum number, which is represented by the letter L, which is kind of unfortunate because a lowercase l, a capital I, and the number 1 look really similar in a lot of fonts. So normally I have to italicize to make sure that, yeah, it's an L, not the other two. But the way L and N are related is that for any given shell / N, L can equal 0 up to n-1, or we often use the term allowed values. So when you're talking about the first shell. No, thought I heard somebody. N equal 1. The only allowed value for L is 0, because n minus 1, 1 minus 1 is 0. When you go to the second shell, n equal 2, then you have two values of L, 0 and 1. And these numbers mean something in some equation that we honestly don't care about. What's important to us is just qualitatively what those numbers mean, what the number of allowed values mean. And however many allowed values you have for that n, that tells you how many subshells are in that shell. So when n equals 1, you only have one allowed value of L. That means there's only one subshell in that shell. When n equals 2, you have two allowed values of L. And that tells us that there are two subshells in shell 2. And so on. If you look at 3, just to do one more example, when you're in the third shell, n equal 3, there are 3 allowed values of L, 0, 1, and 2, and that tells us there are 3 subshells in the third shell. And as you learn more about quantum numbers, you start to realize that there are a lot of convenient little trends. Let's stay here for a while until I get the load out. A lot of convenient little trends to kind of help you keep all of this straight. But one that you see at this point is that the nth shell has n number of subshells. The first shell has one subshell, the second shell has 2 subshells, and so on. Now, dealing with all of these numbers can be kind of a pain, unless you really like numbers, just love numbers. But especially when we get to stuff later on, like electron configurations, dealing with all numbers is be really weird. So to make things a little less weird,
Enemy personal radar in the air. Enemy personal radar in the air.
We have different letters to represent the different values of L. So our main 4 values of L, 0, 1, 2, and 3, these are assigned the letters S, P, D, and F. There's a dude coming. Those letters used to mean something. I guess they still do, but we don't really care. And I guess a lot of people don't care because they decided that after F, we just go alphabetical. So now people will ask, when you get to O, do you just skip P or do you something? Well, it doesn't really matter because it's going to be a long, long time before we even get close to having electrons in an O subshell. When we get to electron configurations, you'll see that we really don't have any G electrons, although we're coming really close. There he is. Excuse me. He buggered off. Where'd he go upstairs?
Enemy personal radar in the air.
Where he went?
Enemy UAV overhead.
Anyway, looking back at shell 1, you've got one subshell, L equals 0. S represents L equals 0. So we call that subshell the 1S subshell. Oh, he's got a drone.
Friendly loadout drop on
There's
the
my
way.
loadout. There's a dude messing around.
We need a recce. Send that flyover.
UAV entering the AO.
How you doing, dude? Bye.
Got gas inbound.
When you're in
Safe
shell
zone
2,
relocated.
again, you've got 2 subshells, S, P, D, and F. No, S and P, which represents subshells L equals 0 and L equal 1.
Be advised, UAV is bingo fuel. RTB for resupply.
In shell 3, I'll do one more since I messed up. I didn't mess up, I just stopped for a minute as I was being hunted. We go, oh, are you kidding me? Pardon me a minute. Where you at, dog?
Enemy personal radar in the air.
So in shell 3, you have 3 subshells. L equals 0, L equals 1, and L equals 2. This is a lot harder than I thought it would be. So we call those 3 subshells 3S, 3P, and 3D. One more, why not? When you're in the 4th shell, you've got 4 subshells, 0, 1, 2, and 3, or S, P, D, and F. And if we're talking about the 4th shell, 4S, 4P, 4D, and 4F. So notice that for those number-letter combinations, the number represents the N and the letter represents the L, which that's convenient. Ooh, I'm going to have to find a vehicle.
Moving up.
So I'm going to get another loadout. So if you're talking about a, I don't know, 7G subshell, you were talking about a subshell that's in shell 7. There it is. Yeah. And the subshell that is L equal 5. No, 4. S, P, D, F, G. Yeah. I always forget to subtract 1, especially when I'm doing this. So where am I at? Oh yeah, subshells. So not only are there subshells in these shells, but it turns out there are sub-subshells, or we often use the term orbital. That's kind of a throwback to Bohr's theory. And just like different N's have a different number of L's, or different shells have a different number of subshells, different subshells can have a different number of orbitals. And the way we figure how many orbitals are present is we use what we call the magnetic quantum number, or M sub L. This will work. And the way M sub L relates to L is for any value of L, whatever subshell you're talking about, M sub L can have a value of negative L up to plus L, including 0. So if you're talking about the S subshell, that means L equals 0. The allowed values when L equals 0 is just 0, because you don't have a plus or minus 0.
Gas is moving in. New safe zone located. Enemy UAV overhead.
When you're talking about a P subshell, P represents L equal 1. So the allowed values of M sub L are negative 1, 0, and 1. And 3 values of M sub L means that there are 3 orbitals in that subshell. And one more. Let's say you're in, let's say you're in a somebody's coming. You're in the in a D subshell. D represents L equal 2. So the allowed values of M sub L are negative 2, negative 1, 0, 1, and 2. So 5 allowed values means that there are 5 subshells in that shell. Or sorry, 5 orbitals in that subshell. Sorry, I was looking at Claymore. And another trend that you see is that whatever L you're talking about, the number of orbitals is equal to 2L plus 1. So when L equals 0, 2L plus 1 is 1. So that means 1 orbital. When L equals 1, 2L plus 1 is 3. And again, the number of orbitals depends on the subshell. It doesn't matter what shell we're talking about. 2p and 3p, both of those subshells have 3 orbitals in them. So there's another quantum number called the electron spin quantum number, but that one is kind of its own thing, and we won't bother talking about that here. That comes into play when you actually start putting electrons in these orbitals. But again, as you go from the shell to the subshell to the orbital, you get a little more specific about where that electron may be. Kind of like as you go from the state to the city to the street. Things become a little clearer about where you might be. Oh, somebody's coming. So let's do one more example since I am still alive. So let's say you're in shell 6. Shell 6 means n equals 6. So there are 6 subshells in n equals 6.
Got gas inbound.
0, 1, 2, 3, 4, and 5. Or S, P, D, G, F. S0, S, P, D, G, and H. I think I did that right. Armor. I'm good. So individually, we can call those 6S, 6P, 6D, 6F, 6G, and 6H. There's a vehicle. So again, the 6S, the 6S subshell. I don't like this. Go there. It has 1 orbital, because any S subshell, no matter what shell it's in, has 1 orbital. Wait a minute, I got some POS. There you at, dog. Where there you are. Excuse me a minute. You know what? I love this game.
Enemy UAV overhead.
So, 6p, again, would have 3 p orbitals. Ooh, gas mask. There you go. Because again, no matter what p orbital you're in, you'd have, p's always come in sets of 3. Because p is L equal 1, -1, 0, and 1. Or 2 times 1 plus 1. You have 5 d orbitals. And for those first 3, you can kind of see the pattern we have for orbitals. It's an odd number sequence because of the +1 part.
Final deployment is making ready. Your window's
So
closing
you'd
fast.
have 6,
Gas
yeah.
is closing in.
So you'd have
Relocating
1
to the
S,
safe zone.
3 Ps, 5 Ds, 7 Fs, 9 Gs, and 6
Friendly
Hs.
loadout drop on the way.
And if you add, here's another little trend for you. If you add, as I'm waiting to die, as you add all of those subshells up, they should add up to 36. Because whatever n you're talking about, you have a total of n squared subshells. Again, shell 1 only has 1. Shell 2 has a total of 4, orbitals. N squared orbitals. Shell 1 has a total of 1 orbital. Shell 2 has a total of 4 orbitals. Shell 3 has a total of 9, and so on. So that'll be it for, I wish I had another rocket. That'll be it for our talk on quantum numbers. You know what? I'm just going to keep recording because if I happen to, I got top 10. If I happen to win this thing as I'm trying to teach you quantum numbers, this is the last take. I've done it a couple other times. First time I screwed up and I kind of just stopped trying to teach and I got second. Last time I got like 17th. I wish I had another rocket. Oh, is that a rocket? Rocket! Give me a rocket.
Gas is inbound. Marking new safe zone.
Come on. Bring your old butt around here. In case anybody's wondering, yes, this is all I've done since the pandemic. Oh man, there's nothing open. What's up, dude? I'm just gonna wait it out. I don't have a building to hide in. Oh man! Let's make it a fight out in the open. All right. Ah, crap. Get out of here!
On right. Strap in.
Get out of here!
Gas is closing in. Relocating the safe zone.
I'm your right.
Less than 5 targets remain.
I know.
Gas is closing in.
All right, at some point we're all going to jump out. All right.
Only 5 remain. We'll secure the win next time. Fought hard out.
So
Return to base for debrief.
that'll be it. I'll see you guys later. The hell was I thinking? I love this game.